Hello and welcome to MyScience Tutorials. In today's video we are going to be looking at an alternating current theory or AC theory. So without wasting much time, let's get started. So what is an AC current? An alternating current is one in which a current changes periodically. So in AC current, okay, the current is not steady, it goes up and comes down, okay, it is not steady. So that is it just keeps going up and down, and then it follows the sine curve rule. Okay, so if we plot a graph of what current, okay, against time, this is time against current, we get to realize the curve goes up and then comes down, and then it goes up and comes down again. Okay, now the highest current we have over here is what we call I naught, which is what we refer to as the peak current. That is the peak current. Now the current and then the voltage at any point in time in an AC theory is given by the formula I, which is the current, is given by what? I naught sine angular velocity t, and then the voltage will be given by what? V naught sine angular velocity t. Now the distance around a circle, okay, in terms of pi is 2 pi. So angular velocity, which will be what? Angular distance divided by time, will be what? 2 pi divided by time. And we know that time is what? Inversely proportional. Time is what? Inversely proportional to frequency. So if we substitute this in place of t, in place of if in place of t over here, we get angular velocity to be what? 2 pi f. So our current in AC theory can be obtained by using the formula I naught sine 2 pi, which is in place of the angular velocity over here, then t. Then our voltage can also be obtained by using V naught sine 2 pi ft. So these two formulas are used in calculating the current and then the voltage in an AC theory. Now let's have a look at how we can get our power in case we are asked to find power. Sorry about that. So when we are asked to find power, we know power is given by what? Voltage times current. And we are saying the voltage in this case is what? V is equal to what? V naught sine 2 pi ft. The same way our current is what? I naught sine 2 pi ft. So this means our power is equal to what? V naught sine 2 pi ft multiplied by I naught sine 2 pi ft. Now if we simplify this, we are going to get V naught I naught sine square 2 pi ft. That is because we have sine 2 pi ft, sine 2 pi ft. If we multiply it, we are going to get sine square 2 pi ft. So this is how we calculate the power in an AC theory. Now this power is called instantaneous power. So in AC theory, if you are asked to find the instantaneous power, that is how we find the instantaneous power, by using this formula. Now remember we said in an AC theory the curve goes down and up. That is the current or the voltage. If you plot the current against time, it goes up and then comes down. The same way for the voltage. And then we have the highest current over here as what? The I naught. Okay, mind you, if we are to take the average of this, okay, because this one is in the positive sector, we will have our current to be what? Negative I naught, which is for this one, then plus I naught. So at the end it will cancel out and it will give us 0. Okay, so for us to actually have a value for our current, we don't take just the normal current. We have a special current that we call the root mean square current or the root mean square voltage. So there are ways we find the root mean square current and then the root mean square voltage, which are the actual voltages in an AC theory. So what do I mean by this? Now because in an alternating current the current and voltage keeps changing with time, it is wise to obtain the effective value for both the current and the voltage. This effective value is what we call the root mean square values. Now, effective current is called the root mean square current, and then the effective voltage is called the root mean square voltage. So in an AC theory, okay, if you are given any voltage, it is not just the normal voltage we know, it is the effective voltage, which is what the root mean square voltage. The same way the current you find in an AC theory is not just any normal current, is what the effective current, which is what the root mean square current. Okay, so if that point has been well established, let's look at how we find the root mean square current and then the root mean square voltage in an AC theory. Now, the root mean square current is simply given by the formula root 2 divided by 2 multiplied by what? I naught, where the I naught is what? The peak current. The same way the root mean square voltage is what? Root 2 divided by 2 multiplied by V naught. Now, for people who like simple mathematics, if this thing is too complex for you to have in your mind, you can just put root 2 divided by 2 in your calculator, then this will give you 0.707, then I naught, and then the root mean square voltage will also give you the same thing, which is 0.707 V naught. Okay, so with these two formulas you can get the effective current and then the effective voltage, which are what we actually need in an AC theory to do almost all our calculations. Now, we need to take note of the fact that Ohm's law still applies in an AC theory the way it is. Okay, so in Ohm's law, in direct current, we know voltage is equal to what? IR. Now in AC theory, you need to note that the fact that we have voltage over here means we have what? The root mean square voltage is equal to what? The current is what? The root mean square current times resistance. Okay, so this is the only difference between the Ohm's law in AC theory and then the Ohm's law in direct current. The only difference here is here we are taking the effective voltage, which is what will be given to you in an AC theory, and then here we are taking the effective current, okay, which is what is needed in an AC theory. So if this point has been well established, let's look at an example which will help us understand what we are talking about so far. So example number 1. Now we have to find what? Calculate I peak voltage, II peak current, III the period of an AC current of means what? 240 volts, 50 hertz if the total opposition is what? 40 ohms. Now let's look at what we are given, okay, or the things that we have. Now they gave us voltage, which is what? 240 volts. Now they give us frequency, which is what? 50 hertz. Now they give us resistance, which is what? 40 ohms. Now we have to find what? The peak voltage, which is what? V naught. Now because we are given voltage, we know the voltage in AC theory is what? The root mean square voltage. And then what is the relationship between the root mean square voltage and our peak current, our peak voltage, so which is the V naught? We know the root mean square voltage is equal to what? 0.707 V naught. So in this case, it means when we want to find our V naught, we just have to make V naught the subject, which will give us what? The root mean square voltage divided by 0.707, which is equal to what? We have over here 240 divided by 0.707, and then the V naught will give us what? The answer we get over here when we put 240 divided by 0.707 is what? 339.5 volts. Okay, so this is our V naught, okay, which is the peak voltage in this instance. Now the II aspect of the question is asking us to calculate the peak current. Now the peak current, okay, the same way we have root mean square current is equal to 0.707, okay, I naught. So it means our I naught is equal to what? The root mean square current divided by 0.707. Now there's a problem here. the problem is, in the first instance we were given the root mean square voltage, which is what we have over here, but then in this instance we don't have the root mean square current, so we need to find it. How do we find it? We use Ohm's law. We know Ohm's law. The root mean square current will give us what? The root mean square voltage, sorry, will give us the root mean square current times the resistance. So if this holds true, it means what we have over here, this implies we have 240 is equal to what? 40 IRMS. Okay, so it means our root mean square current is what? 240 divided by 40, and then this will give us what? 6 amperes. Now if our root mean square current, okay, is 6 amperes, it means what? Our I naught, okay, which is what we have over here, will be equal to what? 6 divided by what? 0.707, and then this will give us what? 8.49 amperes. So this is the value of our peak current, which is what? I naught. Now let's have a look at the third aspect of the question, where we are asked to find the period of the AC current. Now let me just get rid of the first part. Now period is just time, okay, so in this case we are asked to find the period of the AC current. So period will be equal to what? 1 divided by frequency, and then we're given the frequency to be 50 hertz in this example, so we have 1 over 50, which is giving us what? 0.02 seconds. Okay, so this is how we solve questions based on what? The root mean square current and then the root mean square voltage. This tutorial is actually the beginning of the AC theory itself. We'll be looking at the part 2, where we'll be looking at what? Phasor diagrams, where we have the different types of circuit that we have, and then how we calculate their different reactance in case we have an inductor, capacitor, or a resistor. And then the part 3 will be a combination of 2 or more components, that is, whether we combine a resistor with a capacitor, what we will get, and then a resistor with an inductor, how we find the total resistance, which is called the impedance, before we calculate any other different quantities that we are supposed to find. So if you are done watching this video, I think the second link, the link to the second tutorial will be up here anywhere around the page over here. So continue watching the tutorial, and then I'll see you in the next video. So thank you so much for watching, and then I'll see you in the next video. Bye bye.